Welcome to our channel Circuits Analytica. In this tutorial, we will discuss problem on mesh analysis. For the following network, find current Ix and power absorbed by 25 ohms resistor. So for the given network, mark the loops as loop 1, 2 and 3. Mark the mesh currents as I1, I2 and I3. The loop current I1 is given as 5 ampere and the loop current I3 is given as minus 2 ampere. According to Ohm's law, voltage drop across 25 ohms resistance is V25 is equal to I1 minus I2 into 25. So V25 is equal to 25 I1 minus 25 I2. Voltage drop across 20 ohms resistance V2A is equal to I2 into 20. So V2A is equal to 20 I2. Voltage drop across 10 ohms resistance is I2 into 10. So V10 is equal to 10 I2. Voltage drop across 20 ohms resistance V2B is equal to I2 minus I3 into 20. So V2B is equal to 20 I2 minus 20 I3. As loop currents I1 and I3 are known as 5 ampere and minus 2 ampere respectively, no need to apply KVL for these two loops. So let us apply KVL for the second loop. In second loop there are 4 voltage terms. Voltage drop across 25 ohms resistance V25, voltage drop across 20 ohms resistance V2A, voltage drop across 10 ohms resistance V10 and voltage drop across 20 ohms resistance V2B. Moving in the clockwise direction, considering voltage drop across 25 ohms resistance first, as we move from negative potential to positive potential, V25 should be taken as positive. When we consider voltage drop across 20 ohms resistance, as we move from positive potential to negative potential, V2A must be taken as negative. Similarly, voltage drop across 10 ohms resistance V10 as well as voltage drop across 20 ohms resistance V2B must also be considered as negative as we move from positive potential to negative potential when we consider these voltage terms in the clockwise direction. Therefore, we can write V25 minus V2A minus V10 minus V2B is equal to 0, where V25 is equal to 25 I1 minus 25 I2. V2A is equal to 20 I2, V10 is equal to 10 I2 and V2B is equal to 20 I2 minus 20 I3. So applying KVL for loop 2, 25 I1 minus 25 I2 minus 20 I2 minus 10 I2 minus inside bracket 20 I2 minus 20 I3 is equal to 0. Opening the brackets, we will get 25 I1 minus 25 I2 minus 20 I2 minus 10 I2 minus 20 I2 plus 20 I3 is equal to 0. Finally, we can write 25I1 minus 75I2 plus 20I3 is equal to 0. Equation number 1. As I1 is equal to 5 ampere and I3 is equal to minus 2 ampere, equation 1 can be written as 25 into 5 minus 75 I2 plus 20 into minus 2 is equal to 0. 125 minus 40 minus 75 I2 is equal to 0. We will get I2 is equal to 1.133 ampere. So current flow through 20 ohms resistance Ix is given as Ix is equal to I2 minus I3. I2 is equal to 1.133 ampere and I3 is equal to minus 2 ampere. Therefore, we can write Ix is equal to 1.13 minus 2. So Ix is equal to 3.133 ampere. Power dissipated by 25 ohms resistor is given as P25 is equal to I25 square into 25, where I25 is the current flow through 25 ohms resistance, which is given as I1 minus I2. Therefore, P25 is equal to I1 minus I2 the whole square into 25. P25 is equal to 5 minus 1.133 the whole square into 25. So finally we will get power dissipated by 25 ohm resistor is equal to 373.84 watts. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.